Last lesson we looked at transformations using matrices. We're going to backpedal a little bit and just fill in the last couple of gaps in our work. So 3G, transformations of power functions with a positive integer index. So hopefully this is not really new to you, excuse me, and you'll be comfortable recognizing power functions with positive integer indexes. An odd index, remember we described these graphs as cubicy. Okay, I call them cubicy, or like the basic cubic. An even index, describe them as parabolic. So all of them with an even index look parabolic. So knowing that, that will help us sketch this graph here. So we're noting that this is a power 5. So power 5 comes under the odd index or the cubicy style graph. So what I'm interested when I'm talking about the transformations is that, because it's going to be a translation 2 to the right. So it's going to go 2 to the right and 4 units down. So here, at this point here will be our inflection point. Now this negative here means that the standard cubic, if it's got a negative in front of it, instead of looking like that, will go like that. Okay, so what it does is that negative sign reflects in the x-axis. The 3 is a dilation factor 3 from the x-axis. Well, we're not going to worry about that because the dilation will take care of itself. Okay, so next we need the point of inflection. State the coordinates of the point of inflection, the x-axis intercept, and the domain and range. Okay, so this is the point of inflection, so we're going to call that 2, -4. Okay, so the function I can tell is going to come down here, inflect, and continue down there. Okay, so what we'll do is it only asks for the x-axis intercept, it doesn't ask for the y-axis intercept, and it's because it's too big to graph, or it will just make the graph a little bit silly. So let's just find out the y-intercept. So the y-intercept occurs when x is equal to 0. So 0 goes in, it's -2 to the 5 times -3, take 4. Now, -2 to the 5, you're going to have to be comfortable evaluating ones or indices like this. This one, I think there was something like this on the exam last year. So you go to the nearest 2 to the that you know. So I know 2 to the 3 is 8. 2 to the 4 is 16, it doubles. 2 to the 5 is 32. So this is going to be -32. So we're going to do -3 times -32, take 4. Okay, 3 times 32 is, what is it, 96, and it's positive, take 4 is 92. Right, so it's going to be all the way up there. So basically the function comes down here, we'll swing through, so I'm going to start it here. We'll swing through, inflect, and then continue back down. Alrighty, we do need the x-intercept. So x-intercept occurs when f of x equals 0. So 0 equals -3, x take 2 to the 5, take 4, add 4. Divide by -3, I've got -4 on 3 equals x on 2, or x take 2 to the 5. Alright, so what I'll do at this point is 5th root, or raise it to the power of 1/5. And what I've got is x take 2 equals -4 on 3 to the power of 1/5. I'm going to add 2 to both sides. X is equal to -4 on 3 all to the 1/5 plus 2. Now, what does that number equal? Well, because my x-intercept is here, I just know that that's the number. Alright, so I'm going to mark it in there as -4 on 3 to the 1/5 plus 2, 0, and that's the coordinates of the x-axis intercept. So if this is 1, this is 0.5, that's roughly 0.7. So I know that this is going to be roughly 0.7, but because the y-intercept is so big, I think my shape is going to be out by a bit, and I don't know how close I'm going to be. Reality, girls, is that what we would do with this problem in a SAC is we'd take these grid lines off and take the markings for the scale off. So I'd put a marking for 2 on the scale, but no other markings, so that when you go through it, you're not really committing totally to scale. Let's just evaluate it though. Negative 4 on 3, all to the power of 1/5 plus 2, and we're in decimal. So 0.94. So you can see I'm out by a little bit. So really it should come in sharper and come down there, but we're not to know that, and that's a hard one to really sketch correctly. So near enough is good enough on that, and the key thing is to understand what the graph will look like. That's the key skill here. Alright, sketch the graph of y equals 1, take x plus 4 to the power of 4. So this power 4 function here will look parabolic. So what it will do is go 4 to the left, so there, and 1 unit up. Okay, so that's that. Now this negative sign out here is a reflection in the x-axis, so it's going to go 1 unit up, which tells us that we're going to get 2 x-intercepts and a y-intercept that's fairly low. Okay, so let's get the y-intercept first when x is equal to 0. Y equals 1, take away 4 to the 4. Now, 4 to the 4, how to work that one out? We could do 4 to the 3. Now, that's one I just know, that's 64. And then multiply it by 4, so we get 256. Another one is rewrite 4 to the 4 as 2 to the 2 to the 4, and then rewrite that as 2 to the 8 using the index laws. Now, 2 to the 8, well, I know that 2 to the 4 is 16, so I start counting 16, then another one is 32, then 64, then 128, then 256. So 2 to the 4 is 16, that means 2 to the 8 is 256. So this is going to be y equals 1 take 256. That's y equals negative 255. So again, it's a y-intercept that is not really plottable, even though it says it. Okay, now what we'll do is we will get the x-intercepts, and what we know is that they're going to be like here and here. So I think negative 5 and negative 3 will be most likely. So the x-intercepts occur when y is equal to 0, so 0 equals 1, take x plus 4 power 4. Take 1, divide by negative 1, and we got 1, x plus 4 to the 4. Alright, I'm going to undo that by raising it to the power of 4, or 4th root. Okay, and what's going to happen here is, because I'm 4th rooting, or what's called, I call anyway, even rooting, so you're rooting by an even number, what that's going to give you is a plus or minus. Okay, so it's important to note that that gives us the plus or minus, which will yield the two solutions. So I've got x plus 4 equals 1, that means x equals negative 3, x plus 4 equals negative 1, then it's negative 5. So there, our values there. So again, let's just sort of, it's a tough sketch to do shape-wise, because again, the y-intercept is at negative 255, but that will be good enough for what we need. Negative 5, 0, negative 3, 0, and negative 4, 1. What do we need to do? Axes, intercepts with coordinates, state the domain and range of the function. So you can feed it any number in the real number system and it'll power for it. That's no problems. But what can come out of it? Y is an element. It's all the values from negative infinity up to and including 1. I think I forgot to do the range and domain of this one. Yes, I did. That's a fairly easy one for range and domain. You can feed this function any number in the real number system, and because it extends indefinitely in those two directions, our range is also going to be all reals. Okay, so on to the last concept that we looked at today, which was determining the rule for a function from its graph. Okay, so here we've got a power 4 function with the special point, the turning point there, and it also goes through 0, 4, which also is a special point, that's a y-intercept. So what I'm going to do is fill in that into turning point form and then use this point to grab the a value. Let's see how it goes. Y equals a, x take 2 to the power of 4 plus 2. Alright, sub 0, 4, 4 equals 0, which is negative 2. Negative 2 to the 4 is 16. That's going to be 16a plus 2. 2 equals 16 over a. A equals 2, 16. A equals an eighth. Okay, so values. A equals an eighth. H equals 2. And K equals 2 as well. There's our values. Okay, the last problem is this one here. The points 2, 1 and 10, 6 lie on the curve of this equation. Find the values of A and B. Alright, so what we'll do is pop those 2 points in. Let's see what happens. 1 equals A root 2 take 1 is root 1 plus B. Now the square root of 1 is just 1, so this is 1 equals A plus B. And there's an equation. 6 equals A. This is 10 take away 1, which is 9. 9 gets square rooted to become 3 plus B. And here we'll call this equation 1. We'll call this equation 2, and we're going to do 1 take away 2. Right, 6 remove 1 is 5. 3a remove a is 2a, and brilliant, the b's get eliminated. That means a is 5 on 2. Then what we'll do is we'll pop a into this one here. 1 equals 5 on 2 plus b. 2 on 2 take 5 on 2 equals b. B equals negative 3 on 2. Alright, so they were the last few questions in the transformations section. There'll be a couple of worksheets on transformations as well, so make sure you complete those because they will really test you out.